Section 7 of Chapter 4. I am so excited. I think I actually get to teach you something new that you didn't learn in Algebra 1. We'll find out. We're going to complete the square today. And if you will remember, something that will be very helpful for you to remember is that the a plus b squared equals a squared plus 2ab plus b squared. We're going to come back to that. So go back in your brain and kind of remember that. So just to kind of warm up, if we have the equation x squared minus 8x plus 16 equals 25. Now we could subtract the 25 from both sides and factor this and solve it. Another way, though, to solve it is to recognize, well, 25 is a perfect square, and x squared minus 8x plus 16 is also a perfect square because our x squared and our 16 are both perfect squares, and our middle term is half of this and these two multiplied together. So this is x minus 4 quantity squared, because x times x is x squared, 4 times 4 is 16, and 4 times x is negative 4x, times 2 is negative 8x. Ha ha ha. So now we have a perfect square on both sides of our equation. We can simply take the square root of both sides and say now that x minus 4 equals plus or minus 5, which is the square root of 25. And then from there we can solve that by adding 4 to both sides. Now be careful, because this is plus or minus 5, we've got to solve it both ways. So x minus 4 equals 5, or x minus 4 equals a negative 5. So when you add your 4 to both sides, you have to do it both in both equations. So either x equals 9 or x equals negative 1. So there's your two solutions. All right, so remember, if you're taking the square root, that you've got two possible answers and you've got to follow both of those through to the end. Now, that's fine and dandy because this was already a perfect square. What we're going to do now is what happens if we don't have a perfect square? Can we do what's called complete the square? And the answer is yes, of course we can. I wouldn't bring it up if we couldn't, right? So to complete the square simply means to add a term to an expression to make it a square. It's something that's not a square already, but we're going to make it a square. And you remember, the perfect square is the perfect squares on the ends, and the middle term is the square roots of both of those multiplied together and then multiplied by 2. So if we have x squared plus 16x plus something, and we want to find out, well, what is that something that I could add to that would make it a perfect square? Here's what we're going to do. First, we're going to find half of the coefficient of x. So my coefficient is 16. Half of that is 8. Half of that is 8. And then we're going to square it. 8 times 8 is 64. So half of 16 and then square it. So my c is 64. So then x squared plus 16x plus 64 is just x plus 8 quantity squared. So what I want you to do is that once you catch on, it's going to be really quick and easy, but it might take a little while to catch on. Now, what did she do again? So I want you to look on page 285, I believe it is. Yes, 285. At the guided practice number 4 and number 6. I want you to do those. I want you to pause and do those and come back, and then we'll see if you've got it. I want you to do it a couple of times in a row by yourself. So make sure that you do those. All right, and now hopefully you've done them, and if you didn't, you had a few seconds left even then. Okay, so step 1 is to look at your coefficient and take half of it. Half of 14 is 7, and then square it. So C is just 49. And so then remember, also in your guided practice it said, so what is that square now? So x squared plus 14x plus 49 is now x plus 7 quantity squared. All right, this one is a little bit trickier because when you divide 9 by 2, don't use those decimals, stick with the fractions. So you've got 9 over 2 is your half, And then when you square it, you've got 81 over 4. So your binomial now is x minus 9 over 2 quantity squared. And you don't have to figure anything out. Just leave it that way and be done. So if you didn't understand how to do those, if you didn't get those guided practices, stop and go back and look and see what I did again, or write yourself some great questions to ask in class, because we're going to go on. All right. So what good does this do you? This does you good when you want to solve problems by completing the square. So the first one we're going to do is x squared minus 10x plus 1 equals 0. And you look and you say, well, there's an x squared and 1 is a perfect square, but 10 doesn't, this isn't a perfect square trinomial. So what you're going to do is this, and watch carefully and please follow along and write it down in your notes so that you can do this. So the first thing you're going to do is you're going to get rid of this extraness. So you're going to subtract 1 from both sides. So now you have x squared minus 10x equals a negative 1 on this side of your equation, because you want to add something in here that is your that perfects your square. So remember, half of your coefficient is 5, and 5 squared is 25. So you're going to add 25 so that now you have x minus 5 quantity squared. All right, so you want to just make it what you want it to be, and that's fine as long as you do the same thing to both sides of your equation. So you added 25 here, so you've got to add 25 to the other side of your equation. All right, so when you add 25 to the other side of your equation, now you have 24, because you have to combine those. So now you continue solving simply by taking the square root of both sides. So x minus 5 is plus or minus the square root of 24. And then don't forget to simplify inside there. The square root of 24 is going to be, let's see, so it's 24 is 2 times 12, which is 2 times 6, which is 2 times 3, right? And so you can take 2 out, but the 6 has to stay in. So now you've got plus or minus 2 square root of 6. And you still have the x minus 5 on this side. So now you'd simply add 5 to both sides, and you say, well, I can't add 5 in this square root of whateverness, and that's okay. It's all right, just leave it. So x now equals 5 plus or minus 2 times the square root of 6. And you might be tempted to, well, I can just whip out my calculator and get a decimal. Don't do it. Too much work. Don't do it. Just leave it to square root of 6. So x equals 5 plus or minus 2 times the square root of 6, and that is your final answer. And you say, well, that's fine and dandy, but what happens if I've got something in front of that x? Then it doesn't make it nice and neat and easy. Well, I have a solution for that too. Let's do another one. 3x squared, and that's as far as I remember. So let's look at the paper and see what it is. 3x squared minus 36x plus 150. Oh, man. Now you've got it written down. 36x plus 150 equals 0. Now, in order to get that x by itself, you just divide by 3. And you can do that as long as you divide everything in the entire equation by 3. So just divide all the way everything divided by 3. So this is going to now be x squared. This is now going to be 12x. This is now going to be 50. And 0 divided by 3 is just 0. So now it looks exactly like the other problem that we solved. So take the 50 away. X squared minus 12x equals negative 50 on this side. Now we're going to complete the square. So this is where we take the coefficient of x. We want something in this empty spot that will make this a perfect square. So half of negative 12 is 6, and 6 squared is 36. So we add 36 to both sides. So now this becomes just x minus 6 quantity squared, because 6 is what I squared to get the 36, equals, what is that, 14? 30, 40, 50, yes. All right. Oh, negative, because it's a negative 50. The 50 is bigger. All right. So now you've got a perfect square. So you're simply going to take the square root of both sides. And you say, oh no, but there's a negative under the square root. That's okay. We learned how to do that. The negative under the square root comes out as an I. And the 14 is 2 times 7, so there isn't anything, and it isn't any perfect squares in there, so we can leave that. So this now becomes plus or minus, don't forget there's two answers there, plus or minus I times the square root of 14. And this, the square root of a square, is just x minus 6. So then when you add 6 to both sides, x is simply your 6 plus or minus I times the square root of 14. And that's okay to leave that as your answer. That is complete. All right? Now, moving on. So now you know how to complete the square. What good does that do you? Well, let's see in a problem such as this. If we've got a geometry problem where we've got a triangle of area 144, and we know that our base is x plus 10 and our height is 2x. And I want to know, well, what on earth is x? Well, we know that the area of a triangle is 1/2 the base times the height. So let's fill in what we know. 144 is the area, equals 1/2. The base is x plus 10. And the height is 2x. So now we have a problem that we can just solve, right? Well, let's just solve it. So 140, what I'm going to do is let's move things around using the properties that we can use. Let's move things around to make it look like what we've been dealing with. So let's put the 144 on the other side. We can do that. And now when we move this over here, let's move this to the front, because when I do that, 1/2 of 2 reduces down to just x. And so now 1/2 times 2x is just x. So now that I can multiply through and get x squared plus 10x equals 144. And this is already, I don't have to move anything over out of the way. I can make this into a perfect square by adding 1/2 of 10 is 5. And 5 squared is 25, so add 25 to both sides. So now x plus 5, the square root of that, or not the square root, x plus 5 squared equals 140, 50, 60, 169. Oh, yay, guess what? That's going to come out as a perfect square. So now, because we have a perfect square on both sides here, we can take the square roots of both sides. So now we just have x plus 5 on this side equals plus or minus 13 on this side. So subtract 5 from both sides, but don't forget, this is either 13 or a negative 13. So what you could do is you could just say it's either 13, and then you can put over here, or it's negative 13, and put it separated out so that when you subtract 5, you can do it twice. So 13 minus 5 is that 8, 9, 10, 11, 12, 13, yep. And here you've got a negative 18, yes. I don't know why that looked weird to me. 8, 9, 10, 11, 12, 13, yes. 15, 16, yes, okay. Sorry, you know how I am with mental math. Okay, so now x is either 8 or negative 18. So there's two possibilities, but because we're dealing with distance, our negative answer can't be right. So x has to equal 8. And that is the only answer that we'll give to this problem. All right? Moving along. There's a lot in this section. Here we go. So we can use completing the square also to get formulas back into the vertex form. If you'll remember the vertex form from before, when we had quadratic equations, one of the forms was y equals a times the quantity x minus h quantity squared plus k. And we did that so that we could find quickly and easily hk because that's the vertex of our parabola. And that's going to come in handy because that vertex will tell us either the very top or the very bottom of our parabola. So that will give us our maximum or our minimum, depending on which direction our parabola is facing. So let me give you an equation. If we have y equals x squared plus 18x plus 95, and I want this to look like this. Well, we can do that. What we need is, let's see, we need a perfect square in here, right? So for right now, let's just kind of move this 95 over, and let's say x squared plus 18x, and it's okay to have something else in the equation. This can become like our k. So just kind of scoot it over here, plus 95, but we want this to become a perfect square. So let's complete this square. Remember, we take half of the coefficient, half of 18 is 9, and then square it, so that becomes 81. And that's fine to do as long as we, now be careful, as long as we add it to the other side of the equation. So you can't add it to the 95 because that's not where your equal sign is. Your equal sign is over here. So you need to add the 81 to this side. Ha ha ha. So now you have y plus the 81. So that's fine and dandy because now this becomes x squared plus 9, quantity squared, and you still have plus 95, and so it's starting to look kind of like this, but now over here you have y plus 81 instead of just y. Well, that's easy. You just got to get rid of the 81, so just subtract it from both sides of the equal sign. And what we can do is we can subtract it from this 95 here. Ha 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 ha. So now we have y on this side of the equation, and we have, oh, look what I did. So now we have x plus 9, the quantity is squared, not the x is squared. So x plus 9 plus, oh no, mental math, 1, 4, there we go. So now we have y equals x plus 9 quantity squared plus 14. So that is the vertex form of this equation. They mean exactly the same thing. Now we just happen to know that, oh, our vertex is 9, 14, and we can quickly and easily see that vertex. Now the reason that's going to come in handy is if I give you a problem that looks like this, which, you know, I will. So there we go. The height of a ball thrown into the air from a building after t seconds is given by that formula. I want to know what is the maximum height that ball reaches. All right, so if I want to know the maximum height, I want to know, okay, so get in your mind, you're at the top of a building and you throw a ball up. You want to know, well, how high did that ball get before it started to fall? So we have the equation, y equals negative 16t squared plus 64t equals 50, not equals 50, plus 50. Oh man, get it right. All right, so now if I want to know the maximum height, remember the maximum height, if we remember back, the maximum height is the y part of our vertex. It's the k. So if we can put that into that vertex form, all we have to do is put that into the vertex form, and then k is our maximum, right? Well, we can do that. So we've got negative 16t squared plus 64t plus 50. So we want a perfect squared binomial here. Okay, so this negative 16 is kind of in the way. Well, can you get it out of there? Sure you can. So let's pull the negative 16 out of there, or at least out of this part. We're going to leave this 50 alone and kind of tag it onto the end. It's going to be part of our k, so just kind of leave it over there. We want to come up with something in here that can become our perfect square, all right? So if we take the negative 16 out of here, we still have t squared we want to take negative 16 out of 64. That leaves us with negative 4t. And we said we wanted to leave the 50 alone. So we need something to complete the square in here. Well, we know how to do that, right? Inside here, we want this to be a perfect square trinomial. So we take this middle term, take half of negative 4 is negative 2, square it. 2 times 2 is 4. So we're going to add 4. Now be careful, be careful, be careful. Put a big star in your notes. Because remember, we need to add that 4 to the other side of our equation. But because this is in parentheses, this 4 is multiplied by negative 16. So be careful. If your trinomial is multiplied by something, then when you add that third term to the other side, you've got to multiply it by whatever the whole trinomial is multiplied by. So now you've got to take negative 16 times 4 is negative 64 on this side of the equation. So now we have y minus negative 64 on this side, and then we have the negative 16 still, and let's take it and take the square root of that, so it's just, or not the square root, but make it into the perfect square. Now that we found the perfect square, now this is just t minus 2, the whole quantity squared. This thing equals this thing, all right? This binomial squared equals this perfect square trinomial, and then we still got the 50 out here. We're getting really close. It looks a lot like this. All we have to do now is add the 64 to both sides, and I would add it right here because that's what's sticking out there. So now y equals negative 16 times the quantity t minus 2 squared plus 114. So what we were looking for is, what is the maximum height? And from this formula, it looks just like this. We know that the vertex is 2, 114. And if that's the vertex, then this is the max. So the maximum height that that ball will reach is 114 feet. Whew. There's a lot in here. There's a lot of different types of things. The main thing is, can you complete the square? Look for your coefficient of your x term, take half of that, and then square it, and then remember to multiply it to both, or add it to both sides of your equation. And if that perfect square trinomial is multiplied by something, you've got to multiply the part that you're adding by the coefficient that the whole trinomial is multiplied by. All right? Good luck. I am sure you can do it. I have confidence in you. I'll see you soon.